So the idea behind a class, or one of the ideas, is that you can so-called encapsulate the stuff in the class, meaning that you know how to use it, but you don't know how it accomplishes what you need done. We don't know how the turtle works. You know, we can take some guesses that it has something that keeps track of, of an X and a Y coordinate and an angle and a color and stuff like that, but we don't know any of the details. All we know is the API that controls the turtle. So let's write a little class called stack, where you can push things onto it and then you can take things off of it. And yeah, the list class already has, some stack-like commands like pop, but we're going to write our own. So it's going to have two methods attached to it. Push, which places X onto the stack. That's a comment. And pop, which returns the value on the stack, which returns and removes the top value on the stack. And maybe an is empty, so that we can make sure that we don't accidentally, or just a size. Return how many items in stack. So I'm going to go down here and I'm going to write a little bit of code showing how I want it to work. st is equal to stack. Make a stack like that. st.push 3, st.push 4, st.push 5, and then print st.pop. That should print a 5, and then print st.pop. That should print a 4. But it doesn't yet because we don't have our class. So we're going to do that. Class stack, and we need something that when it's run, the way we're going to implement the stack is as a list behind the scenes. There are other ways you could do it, but a list is one way to do it. So we're going to make an init function, and these are double underscores. Define underscore underscore init underscore underscore parentheses self. That's our constructor. A constructor is something that runs when an object of the class is created, just like here. So as soon as we do that, it's going to run this init function. And that's about the time we're going to make our list. Self.l for list is equal to, we're just going to make an empty list. So empty braces. We're going to need a couple of other methods. We wanted a push and a pop and a size. Now every method in a class has to have a first parameter, which is traditionally called self. And you don't pass any data in with it. Just like when we created it, we didn't pass any data in it. If you are going to pass data in, it's going to be in arguments after the self, like in the push one. So def push parentheses self, but we need to take a value too, something that they can push. I mean, to accept the argument being passed in. You need to see this stuff on the bottom, don't you? Let me kind of pull them up. So push self comma value in parentheses. It just takes our list and we're going to append it to the end of the list. Or shall we insert it into the beginning of the list? Don't know. Let's append it to the end of the list. But then when we pop something, we're going to have to take it out of the end of the list. And the list function actually has a pop command. So let's not do that. Let's insert it into the beginning of the list. So insert into position 0 the value that they give us. And just for debugging purposes, let's print the list after that. We'll take this statement out. But that's just to make sure that it looks good after we do that. So push took an argument. It took a value, so that's going to fill in that. However, pop doesn't take any arguments, so all we're going to have is parentheses self. Define pop self. I think I forgot something. I did. It's not l.insert. It's going to be self.l.insert. I messed that line up, guys. Make sure you fix that. So what pop does is it takes the first item off the stack and returns it, but it also needs to remove it. Just like you pop a plate off a stack. Going to be gone. I forgot my colon. Okay. But we need to make sure that the list, that the stack actually has some contents. So if the length, if len parentheses self.l is greater than 0, let's do our good stuff. Else, colon, let's just return the word none. There was no value to get out of it. So what do we got to do? We got to get the first value. Value is equal to self.l index value 0. Then we need to remove that item. del self.l item 0. And then return that value. Change my mind about how I want to do this. I want only one return statement. So I'm going to take that return statement out, and it's going to become nothing there, but here this is going to become value equals none, and then we can return that. Return value. Come on, type. Now there was one more method that I mentioned, size, that we haven't implemented yet. It's just going to return the length of the list. So what should the header, the definition of my size function be? Does it sound like it needs to take an argument, or are you just going to say size? So it doesn't need an argument. So it's going to be def, and then the name of the method, and then what comes next? Yeah, parentheses self, and we can just return self.l. No, wait. Return len parentheses self.l. That ought to do it. All right, there's a half a chance this might work. November 9. L is not defined. Indeed, it's not. What did I do wrong on this line right here? Yeah, it's saying that L is not defined, and it's because every variable that we declare as being part of the class has to be prefixed with this name. The first thing that was passed in there. Exactly, has to be self.L. So we have to modify our push method so that the print, isn't it ironic that the thing that failed was the debug statement that we're going to remove? Let's run it. Alrighty, it worked. We pushed a 3, we pushed a 4, we pushed a 5, and then we took a 5 off and we took the 4 off, and so all that's left in the stack, if we were going to, check the size of it, it would have a length of 1, and if we did one more pop, we would get a 3. And we may as well do that. Let's print the size of the stack down here. Print size of stack is, comma, st.size, and then pop that last one off. Print st.pop. And let's print one more off, and it's going to say none, right? Because there's no data left on it. So those are the 3 lines I just added. Run it. Alrighty. So that works. If we put our stack in its own PY file and we told another programmer just to use import stack.py, they wouldn't have to know, and then we told them which commands. We told them that they could use push X, pop, and size. They wouldn't need to know anything about how it was implemented. They wouldn't know if we implement it as an array. There are no arrays in this language. A list, a weird dictionary. They would have no idea. No idea how at all this is implemented. That's called encapsulation. One of the advantages of encapsulation is that later on, if you decide that you did not do a good job in implementing it, you can go and change the internals of it, and this code down here wouldn't necessarily need to change at all. And as a matter of fact, when you're making changes to your class, you try not to break it. Just because you're adding stuff or you're changing the way it works, the people who've written the code based on your class, that code needs to continue to work. It'd be bad if the creators of the Turtle class suddenly changed it so that, millions of Turtle programs written over the past 20 years no longer worked. Yeah, they did that with Python 2 to Python 3, but that's besides the point. Alrighty. I hope that makes sense. And as I've mentioned before, this variable name, this parameter name, is by convention called self, but it could be anything. Yeah, you can make it an S. Don't make this change. As long as it matches, as long as this matches whatever's the first parameter, you're good. You could call it XYZ, as long as that matched. What if we wanted to make a version of init that would take a list and push everything that was on the list into the stack? What do I mean by that? What if we did this? This isn't going to work yet. But what if we wanted to do this? colors is equal to red, define a list, red, blue, green. And we wanted to make a stack that was composed of those, like that. We can do that. We would have to modify our constructor. We would need to go and add a list parameter to our constructor, but we'd probably also want to give it a default value so that this style constructor would still work. Just an empty list. So we're going to go up and we're going to modify our constructor, which is the init. We're going to make it so that you can pass in an optional list. I've already called my list L there, so I don't feel like calling it there again. Is the word list safe? No. Data. That's really boring.
So wait, you changed the self under init to an S. Does that not require that everything else?
No, it just has to match that. We could call this, I meant to actually change it back, good point. We could call that one Fred, we could call that one Barney, we could call that one Joe and Joe. It's a weird thing that you don't run into other languages where you have this reference to yourself. Other languages use something called the this keyword.
So it can be anything as long as it's consistent within the specific function.
Right, it has to be consistent within that method, but it does not have to be consistent between the methods.
Okay.
Changing it back now. All right, so I still haven't come up with a good name for that variable. ST_list for stack list. But we're going to set it to a default of an empty list so that if they don't pass in anything, we don't need to do anything. So we still need to initialize our list right there. That's a good statement. Space it out just a little bit. But then we need to go through the rest of the list, pushing every value that's in that list. So for every value in ST_list colon, push self comma value. I think that's going to do it. And since we still have our debug print here, we should see it say push red, green, and blue. Push is not defined. Righty. What did I do wrong? Is it self.push?
It's like you can't call push inside the stack.
Push takes 2 positional arguments, but 3 were given. Okay, fine. There we go. That's how I had to change it. Self.push value. I forgot that you call the method name. You have to prefix it with the name of the self variable, and therefore you do not pass the self variable back into the method. Again, it seems counterintuitive to me if you've been programming in other languages like Java or C for a long time. But that's the syntax. It's okay. So you can call your class's methods from within that method. That's totally okay. It's kind of recommended. I mean, once you build up this little language of methods here to call, you may as well make use of them inside your code as well as outside. I want to run it one more time. This, since it's using Python's list class, it can accept data of different types. It can accept floats, ints, and strings just fine, just like the list class can. Whereas in other languages, your lists would all need to be of the same type. If you created a list of ints, they'd all have to be ints. If you created a list of strings, they'd all have to be strings. That's not true of this language. Yes, sir. How far down? This stuff? All right, sure. Alrighty, among the other things we mentioned were the idea of named parameters and optional parameters. We just did an optional parameter here. If they didn't pass in a list, it worked just fine. We didn't do name parameters. I think that's okay. I just want you to remember the concept. So if you do print hello Fred, and then you do sep is equal to, I want underscores instead of commas to be my separator. And then you said I want my end, the end of my line, to be a smiley face followed by a slash n, whatever. Now it's going to print hello underscore Fred, and it's going to have a smiley face at the end of it, whatever. I just want you to remember that that option is there, that you can do that. You can do your own name parameters. The way you do that is inside the function, you're going to set up a dictionary. Guess we could do it one more time. List comprehension I want to mention again because you see it an awful lot in Python. We have this here, this list. Let's say that we want to make everything in it uppercase. We can do that. Colors is equal to v.upper for v in colors. But I forgot the square braces around it. Invalid syntax. Oh, no colon. My mistake. So, when that data got pushed onto the stack, it was all uppercase because this converted it to uppercase beforehand. If you want to print out the elements of your list in a single line, you can do that. And here we go using this kind of weird permutation where we're not storing the results in another variable. And that's okay. We could do print v. I'm using v for value. I could use the whole word value. For value in colors, like that. Prints out every value in the list all at one time. I won't say all at one time, but in one line of code. That's just like writing for value in colors, colon, print value. Not much difference there. But this would take several more lines to code than this. Alright, so it did print out red, blue, green. I want to rewrite this line of code here as a list, as a loop. You're going to have a temporary list first. So I'm just going to call it TMP. And then for V in colors, TMP.append that value. And then colors is equal to that temporary list once we're done. So it's nice that you can do that in one line of code rather than in four. Oh, I forgot the part where we made it uppercase. I guess we could do this here. V.upper, like that. So I just changed that line. Those two do the same thing. This is equivalent to this. This does it in one line of code. This does it in four. I like that. Even though it's a little cryptic, I like it. So this is known as list comprehension. Still haven't quite figured out that name. And this is an example of using list comprehension but not storing the results in another list like we did here. Alright, that may be enough of object of classes for now. I'm scrolling down. Did I go too fast? Anybody need...
Can you go back to the very top for the class definition?
Sure.
Almost one line of that.
In the init method? Well, we're at the top now, so I hope that's right.
Yeah, it's the set that
Okay. Okay, cool. And scrolling down a little bit, we only had a couple lines of code that weren't on there. If I took out these two blank lines, it would have all fit on one page. Alrighty. So what we could do is we have this really cool class. Let's put it in its own file. So we're going to take our cool class, stack class here. First, let's just make a copy of it so we don't accidentally lose it. But take all of the code that's part of class stack, copy it, just from the word class stack all the way to the last line in it. Do file new, paste it, and then do save as, and call it stack with a capital P, capital P, stack with a capital S, .py. Then just kind of minimize that for now. Now that we've got that tucked away safely, go ahead and delete that stack class from your main code from november9.py. And what we can do is this. From stack, import stack. I think I have that backwards. We did make it a capital S, so we have to do it like that. Let's see if that works. I may have goofed something. Nope, that worked. Okay. Not quite at all. Where did this TMP0 come from?
You did that. Colors equals TMP0.
Oh, yeah. Okay, thank you. That was dumb. Okay, so we have written a class and we stored it in a file so that anytime we need it, we can just import it, just like we've been importing turtles and whatever. So now we're going to write a window-based program. Everything we've been doing up so far has been console-based, right? It pops up a black window and you type some text into it. But in the real world, how often have you used a console-based program? Very, very rarely, I would wager. Everything you touch is a window-based program with buttons and things you can click. So that's what we're going to do, and the first one's going to be absurdly simple, but that's okay. It's going to show us just a few concepts. I don't know if we're going to tack it on to November 9B or just make our own new one. I guess we'll just tack it on here. We could always move it into its own file later. So there is more than one user interface library, but the one that we're going to use is one that comes in by default with the Python distribution called TKInter, except Inter is spelled like I for interface. So we're going to just import a very few specific things. From TKInter, import a message box, all lowercase letters. From I should just copy and paste, TKInter, import button with a capital B, We wouldn't want them to be consistent. From TKInter import frame with a capital F. So we're going to do this. Top is equal to TKInter dot capital TK, parentheses in parentheses. That's going to create our application window that we are now going to start using. We have to create a frame. The frame is the actual component in which the pieces, the buttons, are added.
Will the TK work without importing all of TKinter?
Didn't I? I didn't import TK. Okay, fine. Why did I do it that way? Import TKInter. You know what? I'm going to try to make this work. So let's add one more. From TKInter import TK capital T. I'm just going to make sure that works before I go any further. Yeah. See what happened? I ran it and it created a little window. Now we want to create a frame in the window where we can start putting buttons and stuff. Let's go with this. Okay, so we're going to create our frame, and the frame, where's our frame from? It's from our window. Looks like there's a couple of things we could do. We could pass them some keywords. Don't recall what a CNF is. This is how I've always done it right there. Sorry I typed that second word. I just wanted to see it pop up the tool tips again. Now we're going to define a function called say hi that when invoked pops up a little window that says hello. So define, and we could have put this above the rest of the code. Oh, and here's another one we're going to have to add. I should have just gone with it. From TKInter import. No, we have message box. My mistake. We already have message box. So define say hi, and inside that message box, hello there, comma, what's up? And that's all that's going to do. So we're going to create a new button. B1 is equal to button. Can't type. B1. So bring this to the top of the screen. Is equal to button with a capital B. The first parameter is the word top. The second one is the text that we want to be displayed on the button. Say hello. And what command we want that button to execute. When they click that button, we want it to call our say hi function. Say hi. Now we need to pack everything. I'm going to leave off the pack statements for now, and we're going to see that its behavior does not actually work. So here is how we get it to actually sit there and run our window after we have created our buttons. We don't see anything yet. Okay, so we created a frame. Let's pack our frame. F1.pack. Let's pack our button, B1.pack, and let's pack our window, top.pack. And something I tried to do just got me a has no attribute pack. Line 54, but I do see my little window popping up here. Top.pack doesn't work? It's here in my example. Alright, so that creates a little bitty window that when I click say hello, doesn't do anything. Neat.
Go back to your other window.
Console.
Yeah.
Okay, pardon me?
Before you executed the code.
Or the shell.
Go back to.
So go back to my shell. Oh, I see.
That's what I didn't get all that.
Yeah.
We did it a bunch of times.
Okay. Import TK. I'm just trying this.
I did.
TKInter.
So mine digital window and I got an exception to the callback.
Hello there. What's up?
Where mine digital callback.
Well then. Alright, so the problem was this looks like a constructor. It's not a method. What we need to do is messagebox.showInfo. Parentheses, hello there. What's up? With that having been done, I can take out this TKInter in front of it. So this is what our say hi method looks like, slightly modified. When I click say hello, it says what's up. Let's put a second button on there. Let's write another one called goodbye. So DEF goodbye colon messagebox.showInfo. Okay, goodbye, end quote, comma, see you later, end quote, parentheses. And we need to make a button for that command as well, for that function. So B2 is equal to button, top, comma, text equals say goodbye, end quote, comma, command equals goodbye. I'm going to put that on the next line so that we can read it all. We need to pack that one as well. So B2.pack, parentheses, end parentheses. So we have two buttons now. I'll bring the code back. Say hello and say goodbye. I click say hello. It says what's up. We say goodbye. It says okay. This icon, this little feather there, can be controlled by the parameters that you pass to the message box function. Let's go find the web page that was talking about it. Now here's a message box dialog. You can do show info, but you can also do show error or show warning. You want to red alert, go back to your code, and when they choose goodbye, wrong one. Wrong one again. There we go. Instead of show info, let's do show warning. Show error. One of the two. Show error. Now, when we click it, it's got this little red error icon. And so along with info, which is just a blue eye, and error, which is the red one, there's a warning, which is a yellow one. So just a moment. So the last thing I want to add is a data entry field. So for the data entry field, we're going to add, we've already added a message, we've already added a button. It's another kind of control. So let's go and give it a shot. So along with our buttons and our frames and everything, let's declare an entry. Let's just call it text. Text is equal to entry. F1 is our frame. I need to open my cheat sheet here. That's all we do to it? No. And then our text variable is equal to name var. That's the name of the variable. That's the variable that we are hooking up. You know, we're putting a little text box on the screen, a little place to fill in. But there needs to be a variable to contain the data that they're typing in. So we need to make what's known as a string variable. So let's do that as well. I've already gotten lost. Where's my... Here we go. So name variable, or whatever we're going to let them type in here, is equal to a string var. Like that. And then when we create our text field, next lesson is going to be a little bit more formally structured on this stuff. We have name var there. And let's pack our text field. So text.pack. And string var is not defined because I didn't include it. So is entry, I'm sure. Scroll up here and let's add a couple more imports. From TKInter, import string var. And from TKInter, import, what was it called? Entry. Still no joy. Nope, I am not spotting it yet.
I think string bar means a dot something.
I think. TKInter, string var. To create a TK variable, call the constructor.
No, in front of name var in the text command, you need text variable equals. Not there inside the parentheses after the F1 comma.
Oh, you're right, you're right, you're right. You're right. That's what I was missing there. And it was right there. So when I was copying from my cheat sheet. So text variable equals name var. Now we have a place to type stuff. Hello. What's up? Let's make it so that we can type our name there and have it that used whenever we click say hello. So what we're going to do is our method that says hi, let's get the text that's inside of that name variable. So I just called it text, unfortunately, right? I didn't give it a better name. No, I actually did call it name bar. Okay, so name is equal to name var dot get, like that. And when we display a message here, let's go ahead and build our message first. Message is equal to what's up, space, end quote, plus that name, plus another quote, question mark. And then down here, when we're doing our show info, we'll call message like that. Message box.showinfo, hello there, message. So if I type in anything here, like Bobby, and click say hello, it should say what's up, Bobby. So something to note is we're pretty much using what are known as global variables here. Global variables are variables that are defined outside of methods, of functions, but they're used inside of functions. Specifically, this name var is a global variable. And that's not considered great programming. If we built this as a class, if we built our application as a class, then name var would instead be one of the class variables, just like our stack L, you know, our list L was a variable inside the class. But we do have our little application here. And I think that, well, we can add a label to it and then we will be absolutely done with this one. Oh, the text is a little bit complicated. Surely there's an easier version of it, but yeah, we didn't call this. Okay, I'm just going to stop there. We're going to stop there. We'll make the prettier application on Tuesday. All right, anybody need to see anything on this? Did everybody get it working? My bet is that I could remove that import TKInter that I managed to get everything to not rely on that. Yeah. So that's the top. We create our goodies. We have our two method definitions. Excuse me, function definitions. We didn't make this as a class, so they're not methods. We create our two buttons. We pack everything. We could have waited and called text.pack until the bottom along with this other stuff. I don't know where that idea came from. And top.main loop. All right, guys. Okay, I'll be right back there to help. Let me make a Dropbox for this.